So what this does is over in our memory, it allocates 20 bytes. We'll get a couple more. Allocates 20 bytes, and you could access those bytes by using the name buff and some index. So this is index 0, and then this would be buff, index 1, and so on. And when the computer powers up, we haven't, when we create this, we haven't said what the values are going to be. Previously we had said something like, you could say equals, and you could start putting some values in here, 1, 2, and so on. But this doesn't, there's no values assigned at startup here. That doesn't mean that there's no values. Doesn't mean that there's not any values, because you have 8 bits, and 8 bits are always going to have some value, 0 or 1. And technically in the C specification, nothing has to be assigned to this memory location. I think what usually happens though is the compiler may stuff zeros in there. So we could say that these have the value 0. We'll assume they'll have 0 because some compilers do it, and I'm not sure if ours does it or not. But it's just a bunch of zeros, or it's a bunch of values that we don't know what they are. But let's assume we don't know what they are. Okay, there is a variable called CTR that is, it's going to be used as a counter, and CH that's going to store a character. I'm going to write those down too. And they are both USA. CTR, and we explicitly set that to 0, and CH, and it's not assigned. So somewhere in memory, you're going to have CTR and CH, and CTR we know for sure is 0, and CH hasn't been assigned, so we don't know. Actually, I think it's better right now. Let's not assume these are, I'm going to erase these zeros and put question marks in here.
What's the difference between a null and a 0?
Nothing.
Where does it null come from?
In C, they're the same. In C, a null and 0 are the same. In database programming, like if you're doing MySQL or something, you can have null values which are different than a 0 value. But for this class and for C, null and 0 are the same. But I want to start out with these as question marks. Just so you know, we could start with unknown values and be okay. Okay, so the setup sets up our USB serial port. It's there's no 0 here, so it's just plain USB serial. And it also turns pin LED 1 on as an output, but for this first part of this lab, this is meaningless. It's in here. It doesn't affect the program in any way. Okay, so the meat of the program is in the loop, and we talked about last time serial.available and how it works. So if there is a character available that has come from the PC to the Fubarino board, this will return a value other than 0. If nothing has been sent to the board, it returns 0. So if nothing's been sent to the board, and you look at this program and you go, what does this program do if I'm not sending anything? So if I don't send anything, this returns 0. 0 is not greater than 0. So it never runs any of this code. It just skips to the end of the if, and then comes back again and asks the same question again. is there any serial data available? Is it greater than 0? Is the number of characters available in the serial buffer greater than 0? So this program just sits here and basically does nothing, just checking to see if there's data in the serial port. As soon as we send something, let's say on the terminal, we have our little terminal window. We type HI, and then let's assume down here this is set for carriage return. We'll just write CR for carriage return, and here's the send button and our terminal. So we type HI, enter, and the PC will send out the value H, the value I, and the carriage return. And the carriage return, in the C programming language, we represent it with a /R. So when you have single quotes, that basically means an ASCII value, a value that can be looked up from an ASCII table. And so the letter H is a single value in the ASCII table, the letter I is a single value, and the /R, although we have to type 2 characters, it actually comes up as just a single value in the ASCII table that is 13. Let me go back to the ASCII table here. Here's the ASCII table. So a lowercase h would be 68 in hexadecimal, and a lowercase I would be 69. So this is 0x68. This is 0x69. And carriage return, CR, 0D. Okay, so those 3 values are sent to the board. So the next time through the loop, serial available, let's say it's equal to 3. And so 3 is greater than 0, so we go in and run this code. And the first instruction here says serial.read, and that reads 1 character from the buffer, from the serial buffer. It reads 1 character from the buffer, and that buffer is stored in CH, or the character is stored in CH. So it's read and stored in CH. So CH is no longer an unknown value. It's now equal to 68. Okay, the next line says